Hey everyone, thank you for joining us. My name is Anthony Peter, founder of ATEX Software and an AI architect. ATEX Software has deep experience across software development, consulting, training, and real-world AI implementation. And I have worked on cutting-edge AI solution implementation, trained professionals on emerging technologies and effectively using AI tools. Let me introduce our guest. We are joined by Sheila Kishan, who is a partner at Apex Digital AI Consulting and a senior solutions architect. She has extensive experience in the networking and cybersecurity industry, has multiple Cisco networking certifications, had presented at many conferences, and is a passionate learner and mentor. Sheila is currently working on a new course about networking fundamentals with focus on bridging theory and practice for mixed disciplines. Sheila, thanks for being here. Let's start with the obvious question. Why does a business student, a biology major, or a non-computer science student need to understand networking fundamentals?
That's exactly the right place to start. And honestly, it's a question I ask myself every time I redesign this course. Here's the thing, almost every professional today works inside network systems, whether you're pulling data from a hospital server or collaborating on a shared cloud drive, or just wondering why your company's video call keeps dropping. You're interacting with a network. You don't need to be able to build one, but you absolutely need to understand enough to ask the right questions, spot when something's wrong, and communicate with the people who do build them. I always tell my students, you don't need to know how to build a bike, but you just need to have some basic knowledge about how it works.
Interesting. So when you say networking fundamentals, what does that actually mean? Like, where do you start?
I start with the simplest possible model. Network is just devices talking to each other, whether it's two laptops sharing a file or your phone opening up a web page. That's it at the core, and from there we build up. We talk about what kind of devices exist, and devices like your laptop or your mobile, or like intermediary devices called routers and switches that move around traffic. And then we introduced the idea that these devices connect over different type of media. What I mean by that is it could be a wired media like a cable, or wireless, or even your mobile 4G or 5G network. Once students have that picture, they're ready to ask, okay, how do they actually talk? What's the language they use? And that leads us into the rules of the communication, right? The protocols.
Protocols. Okay. That word gets thrown around a lot. How do you explain what a protocol is without losing people?
I use the post office analogy. When you send a letter, there are rules, right? Like you put the address in a certain spot, you use a certain format, you put the stamp in the corner. These are not like arbitrary rules, right? Like they exist because any postal worker anywhere in the world can pick up that envelope and know exactly what to do with it. A network protocol is the same idea. It's like a set of agreed upon rules that lets any two devices, even from completely different manufacturers, communicate reliably. The most common protocol that we use is TCP/IP, where the IP handles the addressing, like which device it needs to go to, and the TCP handles the reliability, making sure that the data actually arrives in the right order. A quick test that I do is I ask my students to describe ordering a pizza on Swiggy or Uber Eats. There's a set of steps or protocol they follow naturally. They already understand the concept. We're just applying it to networks.
Awesome. I really like your post office analogy. That makes it a lot more clear. You mentioned IP addressing. It seems like one of those topics that either clicks immediately or completely doesn't. How do you handle that?
Yeah, IP addressing is where I lose about 20% of the room if I'm not careful. What helps is grounding it in something physical first. Like every house on a street has a unique address. So the mail can find it. An IP address does the same thing for a device on the network. We cover IPv4 first. That's a version of IP addressing. Every modern device has one, including your mobile or your PC, right? Then we talk about subnets, how you group those individual devices into smaller, manageable neighborhoods, and that's where some eyes just glaze over. My trick is to draw it like literally on a whiteboard. Draw streets within a city. The city is the network. The local neighborhoods are subnets. Each house is a device. Visual learners get it immediately. And then we talk about why IPv4 addressing is running out and why the newer version, which is IPv6, exists. That usually sparks good discussion.
Interesting. Let's talk about the OSI model, right? Like, do you teach it? And also, some people think it's outdated or too abstract for an intro course.
I do teach it because I think it's very foundational to any kind of networking concept. But I teach it as a thinking tool, right? Like it's not a rigid doctrine. The OSI model has different layers. It has 7 layers, right from the physical layer, which is your cables, to your network, which is the addressing, to all the way up to application, which is, the application you actually access. The beauty of it is that it helps you isolate problems. Like imagine you're trying to access an application or a web page and it's not loading, right? There could be any number of issues. It could be that a physical cable is unplugged. That's a physical layer issue. Or the device can't get an IP address. That's a network layer issue. Or maybe there's a problem with the actual application or the web server. That's an application layer issue, right? So for any students going into any technical or managerial role, being able to say, hey, this looks like a network problem, right? Like a network layer problem is genuinely valuable. It gives you a shared vocabulary with the engineers. I typically spend about a week on it, like use real troubleshooting scenarios. And I also resist the urge to go too deep into a single layer. I do have a favorite mnemonic for the layers as well. Please do not teach students pointless acronyms. Students never forget it.
That's a good one. Like, I mean, that is in my mind right now. That's an awesome mnemonic. What about security? When does that enter the picture in a fundamentals course?
Early and often. I don't think of security as a separate subject or a module to add at the end. I thread it through everything. When we talk about protocols, I introduce the idea that some protocol exchange information in plain text, which means anybody on the network could read it, and that immediately raises the question: how do we protect it? That leads to the different encryption methodologies and protocols. When we cover wireless network, we talk about why an open Wi-Fi hotspot, like the one in shopping mall and airport, is fundamentally different from your secure home network or your campus college network, right? And then we talk about routing. We talk about how the traffic can get intercepted. The reason I weave it in rather than adding it on top is security isn't just the add-on feature to a network. It is a property of every design decision you make, and students need to internalize that security mindset from day one.
Awesome. That's a very valid point, right? Like we needed to build security from the ground up, not an afterthought. That's very valid. Last question. What's the one thing you want every student to walk out of this course believing, regardless of their major?
The networks are not magic, like they're not just for your IT engineers. These are systems built by people, governed by rules, and they fail in predictable ways. If you understand the fundamentals, how devices communicate with each other, how data moves, what can go wrong and why, you're a more capable professional in almost any field. You'll ask smarter questions, you'll make better decisions about technology that your organization depends on. And you'll never be the person in the room who shrugs and says, I don't know, it's an IT thing, right? That's what I'm trying to eliminate, that learned helplessness around technology, because the network is everyone's problem, especially when you're talking about like artificial intelligence that's coming into almost every field. Um, Network is foundational to that. And honestly, once students realize that they've been doing networking every time they use their phone, they stop being intimidated. That moment of recognition is the whole game.
That's a great perspective. Thank you for sharing your insights with us today.
My pleasure. Thanks for having me here, and thanks for the conversation.
And thank you, everyone, for watching. We hope this discussion helped you better understand networking fundamentals and how it's shaping our world. Thanks again.